Okay, we are recording. Today, I'm going to teach you a software that we will be using to do some lab. And we are going to get familiar with the Linux operating system today at the level of networking. So I sent yesterday the due date for homework number 1. So be sure you do homework number 1 and you submit your answer before the due date, no? Be sure you do it, please. Okay, so the software that I want to use is called GNS3. We have it in the cloud. I will send you the link so you can download it at home and use it. So here in this computer, we have installed a hypervisor. It will allow me to create virtual machine. So there are several hypervisors around. One that is called VMware Workstation Player. This is the one that we are going to use today. And there is another one from Oracle, which is called VirtualBox. I'm going to use VMware Workstation Player. So you will have to install it. So let me show you. We are going to make a search of download VMware Workstation Player. Download VMware Workstation Player. So here I am. This is free software. So here, for example, my operating system is Windows. I will click here and it's downloading, as you can see here. And once it's downloaded, of course, it's always like the same thing in Windows. You double click the installer and follow the steps. There is a point where it will ask you for a license, and there will be an option to say, I'm going to use it for learning purpose. So you just are going to check this option and you don't have to put a license. So this is the installer in my download folder. I just click on it and follow the step. If you are using Mac OS, the software is called VMware Fusion. So let me go and search for VMware Fusion. This is the one that you will have to install if you use Mac OS, no? So you will go, oh no, this is not a good place. I want to go here. Download, I'm in the web page of VMware, download VMware Fusion. So here, VMware Fusion or Fusion Pro. So you just don't download the Pro version, the Fusion version, which is the free one. So Fusion 12 player, this is the one that you will have to download. So it asks you to register to use the personal license, so you will do it. I've never done it in Apple. So in the cloud, I will give you a link where you can download a virtual machine that is already done. So it will be a zip file. Here is the zip file. It is on my desktop, as you can see, and it is already uncompressed, but you just double click on it and you have the folder and you just move the folder to your desktop and you will have this. So this is the software that I'm going to use today, which is called GNS3, and it will be inside the virtual machine. So I'm going to open this folder, and inside this folder, you have this icon, which have three square that are overlapped. The file is called Debian 10.11-gns3.vmx. So I'm just going to double click on it. And if I already install VMware Workstation Player, it's going to start the virtual machine. So you see, it's a non-commercial use only. And okay, here it's tell me that there is a new version. I'm okay with the version that I'm here. There is a new version of the software, which means that the one that is installed in this computer is not the last version. It's not a problem, okay? So this is my virtual machine, and this is a Linux machine. So this virtual machine have two users, an administrative user, which is called root, and a normal user, which is called Eric. So as user, you are going to enter as Eric. So I'm going to type here Eric for the logging, and the password is internet2. The password of Eric is internet2. You don't have to worry about these details because they are inside the folder. Inside the folder, there is a README file. Let me show you the content of this README file to have the information. So let me put it big. It say we have two users. One is the admin user, which is called root, and the password is TOOR, which is root backward. And we have another user, which is a normal user, and the password is internet2. So here, as user, I'm going to put Eric, and the password is internet2, and it will launch the Debian virtual machine. So what I have in this moment, as a host machine, I have Windows 10, and as a guest machine, I have Debian. So I want just to work on my Debian machine. I can maximize this window. I'm going to do it. But before I do it, I need some file, the exercises that we are going to do. So I'm going to pass them inside the virtual machine. So when you need to pass a file from the host machine to the virtual machine, you can drag and drop it. So let me show you. I'm going to open my pen drive here. My pen drive. In my pen drive, I have some file that I want to pass. So I'm going to go there. This is not the course, 450 lab. Okay, so for example, let me put them side by side so that we can see both. Okay, so let me close this one. We don't need this one anymore. Let me close this one also. So I want to do this first lab, which is called here static Debian 01. So I'm going to drag and drop it in the virtual machine, and it is there in the virtual machine. I need also this file. I'm going to drag and drop it in the virtual machine. This will be the second exercise. Hopefully we will arrive to the third exercise. I'm going to drag and drop it. Okay, so I don't need my Windows machine anymore. I can maximize my Linux machine. So you see this icon that is there? It says enter full screen. So I'm going to click on it. It's like I don't have Windows anymore. I just have Linux, as you can see. So let me show the first exercise that we are going to do. I just double click on the file. It's a PDF file, and it's open a software that allows me to view the content of a PDF file. I want to do this lab. So in this lab, we will have 4 computers. There will be Linux, and the operating system that they will run is Debian. So as you can see here, we have a hub, and the network that we will be using is 10.27.0/24. And the IP address of PC1 will be 10.27.10. The IP address of PC2 will be 10.27.20. The one of PC3 will end with .30, and the one of PC4 will end with .35. So you see, we just put the end of the IP address, and the people understand that the IP address of PC4 will be 10.20.7.34/24. So I want to do this lab. So I'm going to start. Here we have an icon. It's a chameleon, kind of lizard, which corresponds to the software that I want to use, which is GNS3. So I'm going to click on it, and it will start the software that I want to use today. So the first thing that it will show me, you need to create a project. Let's call it, for example, Linux Lab 01. Okay. So it put it the name here and have the software here. So let me put it a little bigger, but I need both. So I'm going to do that. I hope you can see both. Yeah, you can see both. Okay, so I need 4 PC. So look here, we have the area where we will do our network. And here we have the tools. So I need a PC, which is an end device. Those are the end devices. Here we will have the switch, which are layer 2 devices. Here we will have the router, which are layer 3 devices. And here we will have a tools that will allow us to do cabling. So I need some PC. So I'm going to click here, and those are the PC that are available. Those are the end devices that are available. So I'm going to use Debian 7. You see here we have an option that says Debian 7. I'm going to drag one in the working area. And we have our first PC. There is a name by default, which will be this name, Debian 7-x64-1, because it's the first one. So I'm going to change this name. To change the name, I can double click on it and change the name. I want to call it PC01. Okay, I need a second PC. So I can drag another PC here, double click the name and change it, no? PC02. There is an easier way to do that. For example, if I want a copy of PC2, which is what I want, I can right click. So I have the context menu. And in the context menu, there is an option that is called duplicate. And as you can see, it will create a PC. The name was not correct, so let me change the name. And I'm going to duplicate again PC3, and I will have PC4. Let me change the name to PC04. Okay, I have the 4 PC, as they say here. Let me put them as they appear in the PDF file. So they are aligned, like that. Okay, we have the 4 PC. Then we need a hub. The hub will be here. Here we have switch and hub. So if you look here, we have something that says Ethernet hub. This is exactly what I need. I'm going to drag it here, and it will give me a hub. The name by default is hub1. I can just change it to hub because we will not have several hubs, so I can just call it hub. Let me put the name below. And then I need to do connection between the PC and the hub. The hub have 8 ports, and the PC have just one network interface card. So let me take the tools that will allow me to make connection. So I click here, and I come to my PC, and I click on my PC. It will show you that there is only one network interface card, and this network interface card is called ETH0 for Ethernet 0. So I click on it. As you can see, I have a cable, and I will click on the hub. It will show me all the ports of the hub. So the hub have 8 ports from Ethernet 0 to Ethernet 7, and I can connect the PC to any port. There is no difference. So I just connect it to any port. So I make the first cable between PC01 and the hub. I need another cable between PC02 and a port that is still free in the hub. So I click on PC02. I click on PC02, it shows me that there is only one network interface card available. And here, I already use Ethernet 4, so it's not available, but all the other ports, the other 7 ports are available. Let's say that I put it in Ethernet 1. So I have my second cable. Let me do my third cable. And let me do my last cable. This time I'm going to go from the hub to the PC. There is no difference, no? So I take one port that is free, and I go to the PC. Okay, I have all my connections. Let me put the name below. Okay, so I need to start PC1. PC1 is powered off. So I need to power on PC1, and I need to simulate that I sit in front of PC1. to configure PC1, to type command in PC1. So how do you start PC1? How do you power it on? So you right click on the icon and it shows you the context menu. And here you have a start button. So I'm going to click on the start button. As soon as I click on the start button, the monitor or the console of PC1 will appear. So, sorry, I have to double click it for it to appear. Here is the console. So PC1, on the top it says PC1, is booting. So this is a Linux operating system without graphical user interface. So it will just allow me to type commands. This is exactly what we want. We want to get used to the commands. So look, it's saying me, please, can you give me your login? So all these PC have two users, the same two users, root, which is an administrative user with the password TOOR, and the normal user, which is Eric, with the password internet2. So normally, unless you are going to do an administrative task, you should log into a computer as a normal user. And when you are going to make an administrative task for a temporary period, you escalate your right to be root, do the task that you have to do as an administrative user, and then come back as a normal user. So here I'm going to enter as a normal user, which is Eric. So I type my login, Eric, and it asks me what is your password. I'm going to type internet2. So this information is also here. So there is a README file here. If I display it, it will say me you have two users. One is Eric with password internet2 and the administrative user, which is root with password TOOR. Okay, so I am inside Debian. I am inside my first machine, as you can see. So the prompt say that I am user Eric at a computer that is called Debian. So one of the first things that I want to do is to change the name of the computer and to call it PC01. By default, they will be called Debian, but you can change the name. And then we will put an IP address to this machine. So first I'm going to change the name. So to change the name, there is a command that is called hostname. Hostname space the new name. This command, when you type it, you need to be administrator. So if I type it, let me try to type it like that, hostname, and I want to call it PC01. Let me put it a little bigger. Control. Okay. You see it a little bigger, no? So let me try to do that. Look at what the command say. You must be root to change the host name. So it told me this is only the administrator of the machine is able to change the name. So I need to be root. So the way that I can change my identity is there is two ways. There is a command that is called su for switch user, and there is another command that is called sudo. I'm going to show you the su command for now. So before I do it, I want to know what is my identity. I already know that I am Eric, but there is a command that is called ID. I can type the ID command, and the ID command will tell me you are the user Eric, and the user Eric has a default group, which is Eric, and belong to all those groups. It belongs to the group Eric, CD-ROM, floppy, audio. Okay, so it's just to verify that I'm the user Eric. So the command is called su, with an option that is dash, su dash. So I'm going to type it, and of course, this is a way to say I want to escalate my privilege. I want to be an administrator of the machine. So it will tell me, give me the password of the root. And since you know the password of the root, you are going to type TOOR. And as you can see, look the prompt previously. It was telling me I was the user Eric in a machine that is called Debian. Now the prompt say you are the user root in a machine that is called Debian. If I type the command ID, look, it doesn't say that you are the user Eric anymore. It says that you are root. So now I have administrative privilege. So I can type the command hostname and the name that I want for this machine. I want this machine to be called PC01. Now, the effect is not right away because when I enter the shell, the name of the computer was Debian, so it is not updated here. So the name of the prompt will reflect the name of the computer when I started the shell. I started the shell when I enter as user Eric. So to see the change, I need either to type a command that will change the prompt or to exit and run the shell again. So what I'm going to do here, I'm going to type first exit, and I will return as a normal user because the switch user command put me as root. Now with this exit, I came back to a normal user. If I ask my identity, I am Eric again. And then I'm going to type exit to log out. Look at the prompt here. Look at what the login invitation. It says that the computer is called PC1. It doesn't say that it's called Debian anymore. So let me type my username, Eric. Internet2 is my password. And look at the prompt this time. This time it says you are user Eric in a computer that is called PC1. So I did change my name, the name of the computer, and I can see this reflected in the prompt that I have in the shell that I'm running. Okay, now I need to check my IP address to see if I have an IP address. So there is a command that is called ifconfig for interface config. This is an administrative command also. So before I use it, I'm going to switch user and I want to be a root. So it asks me the password of the root. I'm going to type tour. I'm going to type the command ifconfig. Show me the configuration of the interfaces. So by default, we will have two interfaces, the loopback interface and the Ethernet 0 interface. The Ethernet 0 interface is the one that I use here. Look at it, say Ethernet 0 to connect to the hub. So if you look, we don't have IPv4 address in this moment in this interface. So I can tell that I want to add an IP address in the interface that is called ETH0. So the syntax of the command is ifconfig, the interface where you want to add the IP address. This will be ETH0. Then the IP address that you want to add. So the IP address that I want to add to PC1 is 10.20.7.10. Then you use net mask and you put the net mask. So this network is a /24. So I'm going to put 255.255.255.0 and hit enter. So now if I type again ifconfig, it will show me new information for this interface. So here it was just showing one IPv6 address, which is there. So let me do it again. So we have information of the loopback interface. And now look at on the information of the Ethernet interface. We still have the IPv6 address, but now we have the new address, which is an IPv4 address that I specify. So look at 10.27.10. The net mask 255.255.255.0. And look at the broadcast address. I didn't specify the computer, the broadcast address, but it was able to compute the broadcast address. The broadcast address of this network is 10.20.7.255. So I put an IP address to PC1. So let me do the same thing with PC2. So I don't need to work with PC1 anymore. So I'm going to minimize this for now. It's like I'm leaving, I was sitting in front of PC1. I'm leaving and go to PC2. So let me just minimize it. When we need it, it is there, and we can just maximize it again, or just restore the size, no? So PC2 is still off. So we are going to start PC2. So I right-click on PC2, click on Start. It is booting. And if I want to see the console, I double-click on the icon, and PC2 is booting. When it's booting, it's loading the operating system into memory. So it's exactly the same machine. So it asked me to log into it. Let me log as Eric, and the password will be internet2. I am inside the machine. So I want to change the name, and I want to put an IP address. So what should I do if I want to change the name and to put an IP address? So those are administrative tasks. The user Eric cannot do that. User Eric have limited privilege on the machine. It cannot do administrative tasks. So I'm going to type switch user SU dash. Okay, it's going to ask me for the password of the administrator. Let me type TOOR. Now with the ID command, I can verify that I am an administrator. So I'm going to type host name, PC02, ifconfig to verify the configuration of the network. So the Ethernet 0 do have an IPv6 address, but it doesn't have an IPv4 address. So what is the IPv4 address that I need for PC2? 10.27.20. So I'm going to type ifconfig ETA0 10.20.7.20 net mask 255.255.255.0. Okay, it has its IP address. I can verify it, and as you can see, this IPv6 address was already there, but now it has an IPv4 address, and this IPv4 address is 10.20.7.20/24, and this is the broadcast address. So both PC1 and PC2 have an IP address. You might say, yeah, I don't see here PC2. That's true. So if we want to see it reflected, we need to start the shell again. So I can do, look at what I did. I create a subshell, and I can see the name reflected. So that will be one way to do it. I exit the subshell. As you can see, it came back to the previous name. So another way, this is the one that I showed you previously. In this moment, I am the root. I'm going to exit the command switch user. I am the normal user. I'm going to exit. And now this PC know that its name is PC2. I'm going to enter as Eric internet2. Okay, so we have PC1. Let me maximize also the window of PC2. Make it bigger, sorry. Okay. We have PC1 and we have PC2. This is the IP address of PC1. So there is a tool that is called ping. Ping is a tool that will tell you if you can reach a remote IP address. So I'm going to use this command ping, and I'm going to try to ping PC1, PC01. So the IP address of PC01 is 10.20.7.10. So ping will send a packet to 10.27.10. On 10.27.10, which is PC1, will return me the same packet. So the packet will go and come back. It will make a round trip between me, which is PC2, and PC1. And it will, the command ping will show statistic. It will show you the time, the round trip time. The time it took the packet to go from PC2 to PC1 and come back. And it will show you, at the end, it will show you the minimum round trip time, the average round trip time, and the maximum round trip time. So let me do it. So it will keep going like that, this command, until I Control-C it to kill the process. I'm going to type Control-C and it stops. So look what happened. Here we have, I sent the first packet. So it went to PC1, PC1 sent it back, and it come to me. And it took 3.59 milliseconds to go and come back. Then PC2 sent a second packet to PC1, and this time it took 1.38 milliseconds. A third packet, a fourth packet, a fifth, a 6, 7, 8, 9, 10. In total, 10 packets. Then I hit Control-C. Look at the statistic. The statistics say, I sent 10 packets. I received 10 answers. So the packet lost. Sometimes you send them packets and you don't receive the answer. So in this case, the packet loss was 0% because all the one that I sent came back. Okay. Then we have the round trip time, RTT. So it will show the minimum value. So this is the minimum value. So look at all this time. So where is the minimum value? The minimum value is in the third one. Then it show me the average. So this is the average of all these 10 values. Then it show me the maximum value. This is the maximum value. Look at the maximum value was the first one. Okay, here you have several numbers. And it's show me also the standard deviation. So I can, if I want, I can verify that this is the average. No, I can use a calculator. For example, we have BC. Oh, it's not installed. So do I have Python 3? Yeah, I have Python 3. Why I just have Python? I have Python. So let me use Python to verify that I will have to add up 10 numbers. So 359 plus 138 plus 0877 plus 174 plus 102 plus 161 plus 102 plus 141 plus the last one is 0986. Oh no, there is another one plus 144 divided by 10. This is my average. As you can see, 1.507. Well, he computed and he got this average, no? So this is the average, as you can see. Let me get out of Python. I don't need Python anymore. And I'm back to the shell. So this is the ping command. So look, PC3, I'm trying to go on ping. I'm trying to ping PC3. The IP address of PC3 is 10.20.7.30. So 10.20.7.30. What do you think is going to pass here? So PC3 is not on. PC3 cannot answer. So of course, I will send the packet, or I will try to send the packet and I will not get an answer. So everything is going to fail. So let's do it. So you see it doesn't show a result. And destination host unreachable for the first one. Okay, let me Control-C it. So we make 6 attempts to reach PC3. So it's, oh, it was 8 attempts in the total. I can see only 6 here, but it was 8. So it's, say I make 8 attempts, I receive 0 answer. So 100% of them are lost. And it doesn't show you the round trip time, because if I need the round trip time, I need at least 1 to go and come back. So it doesn't show you statistic on the round trip time, the minimum, the average, and the maximum round trip time. Okay? So I'm going to show you some option of the ping option, of the ping command. So let me go and ping back PC1. And for example, you can use -C, send only 4, and stop. So it's the number of times that I'm going to send a packet to PC1. So first, second, third, 4, and it's stop. So if I say do it 2 times, first, second, and it's stop, and it show me statistic on it. As you can see, every time that I see that, is that the ping is working. So from PC2, I can ping PC1. Of course, from PC1, I can also ping PC2. So let's do it. Ping. I want to do it 3 times. So this option -C is count. Count up to 3 packets. So 10.20.7.20. This is the IP address of PC2. First time, second time, third time, and it shows me the statistics. So it does work, no? So let me try from PC1 to ping PC3 forever. So I don't say a number of time to count. So it will try all the time until I Control-C the command. So of course PC3 is not ready. So this command in this moment is a failure. Okay, let me start PC3. So I come back here, PC3 is off. I'm going to start it and double click on the icon so I can see the console. Here it's booting. Let me maximize, let me increase the size of the monitor of PC3. This is the monitor of PC3. Look at the ping still fell. Why? Why do you think the ping still fell? Exactly, we have not put in PC3 the IP address. PC3 doesn't have an IP address. So let me enter as Eric, internet 2. Let me switch to root. So the password is tour. Let me say that the host name will be PC03. Let me type the command ifconfig eth0 10.20.7.30 net mask 255.255.255.0. So as soon as I hit enter, PC3 will have this IP address and the ping should start working. So let me hit enter. I just hit enter, look at the ping. You see, before it was saying destination unreachable, and now it's telling me, okay, they are working. If I Control-C it, look at, it say in total, I sent 100 packets. I receive only 14 answers, which are the last one. So it show me statistic. 87% were lost. Only 13%, which is this one, came with an answer. And it showed me also the minimum round trip time. So if you look at all this number, the minimum is this one, 116. It showed me the average and the maximum. If you look at all this number, the maximum is 2005. It is there, 2005. Okay? So now, from PC1, I'm able to ping PC3, or I'm able to ping PC2. I'm able to ping both. You see? So there is something, we saw the broadcast address. The broadcast address is 10.27.255. If I try to do it, look at what the command tells me. Do you want to ping the broadcast address? If you want to do it, please use also the option -B. So I'm going to add the option -B. Look at, I'm in PC1. And I'm going to ping the broadcast address of the network. What do you think will happen? So what is a broadcast? We have one sender, which is PC01, and who should receive the packet? All the computers in the network. So in this moment, PC2 and PC3 are up. PC4 is not up, so it will not receive the packet. So PC2 and PC3 will receive the packet, and they will answer. So look, if I do that, let me do it. And let's wait for some answer. Okay, so I don't see any answer. So it might be because the broadcast is not allowed in PC2 and PC3. We can check that because you can enable or disable it, the answer to the broadcast. Or it might be reverse resolution. Let me do a man ping to see if I can see something about resolution. Name resolution. Disable. No, so it should be, I think this will be what yeah, I wish it will answer. So I think the ping is not allowed. Let me try another IP address, 224.0.0.1. Yeah, okay, no problem. So this is what I wanted to show you in this lab. Okay, so I want you to do the same lab in your house. Okay, we don't have time to do the lab here, so I ask you to do it in your house. So before I finish this lab, PC1, PC2, and PC3 are on. I need to shut down them. So there is a command. There are several commands to shut down a computer, a Linux computer. So you need to be administrator. I am administrator, for example, in PC3. I can use the command init0. It's one way. Let me shut down PC3. Before I do it, by the way, let me change its name to PC03. So to see it reflected, let me exit and enter again as user Eric Internet 2. So as you can see, the computer knows that it's called PC3. And if I look at its IP address, it's know that its IP address is 10.27.30/24. The two commands that I typed to change the host name and the IP address, those commands are called non-persistent. Do you know what does it mean? Non-persistent? It means they are not stored in any file. If you boot the computer, they are just in RAM. If you boot the computer, the information of the RAM is going to be lost. So the computer, when it's come back, it will come back with the name Debian, and it will not have the IPv4 address. So let's do it. Before I do that, of course, since I'm going to reboot the computer, I need administrative privilege. So I'm going to switch as an administrative user and put my password, which is tour. And there is a command that is called init0. init 0 will shut down the computer. So you will see that it starts killing the processes. We also call them the daemon that are running inside. So let me do init 0. Look at it, start killing the processes, and that the monitor is off. So if I look here in GNS3, PC3 is off. You see this red dot here? Say that PC3 is off. Let me start it again. I click on the icon, the context menu come, and I click start. And I double click on the icon to see the monitor. So it is booting, it is putting up the processes that it needs to run. Look at the name. It forgot its name. It thinks that it's still called Debian. Okay, I'm going to do something that I should not. I'm going to enter as root from the beginning to make it faster. So I don't have to switch to the root when I need to make an administrative command. I should not do that. This is a bad practice. And it's go against security. But I'm going to do it because we need to go a little faster. So let me type root as a user and tool as password. So as you can see, if I type ID this time, I'm the administrative user. So the command that I show you were not saving files, so they are not persistent, which means that if you reboot the computer, all these changes that you have made on the computer are not saved. So we do have some file where we can save the name of the computer. When we want to change the name of the computer, we need to edit two files. So I'm going to use an editor that is called Nano. It's a very basic editor. So Nano, and I'm going to put the name of the file that I want to edit. So the host name is in a file that is called /etc/hostname. So you see the command nano space and the name of the file /etc/hostname. I'm going to hit enter, and I am in Nano, which is an editor, and there is only one line in this file. And as you can see, this line says Debian. This is the name that the computer has by default. So I'm going to remove this name, and I'm going to put PC03. So now it will be stored in a file, not only in memory. So I make a change in the file. So here it says that I make some change. In the lower line, you have help of the editor. So if you want to write your change, it says use Control-O. So I'm going to hit Control-O, and it will tell me you are about to write. Do you want to write it with the same name, which is /etc/hostname? Yes, I just want to overwrite this file. So I'm just going to hit enter and accept the name that is shown. I make change. So look, it says one line was written. So now that I change the file, I need to exit. So if you look here, Control X is to exit. So let me do Control X, and I'm out of Nano. I'm back to the shell. So I changed the first file. There is another file that I need to change. So I'm going to use Nano, and this file is the etc host file. So let me enter. Let me hit enter. So you see here, those are loopback addresses. You remember that the class A127 have a special purpose. It's for loopback addresses. So look at the computer here say, okay, I am Debian. That's my short name. So I want to tell it, no, you are not Debian anymore. You are PC03. And if I use my full qualified domain name, it say here, I am Debian at debian.jsu.edu. So I'm going to say, no, you are PC03.jsu.edu. This is the name of the computer also. So I make some change. I need to hit Control O to write it. So let me type Control O. Here it shows me the name. I'm just going to hit Enter. So I change and replace the file. It says 7 lines have been written. Now I need to exit, Control X, and I'm done. So the next time that I boot the computer, it will know its name because I changed it to file. Let's do it. So to boot a computer, you can use the command init6. So init0 will shut down the computer. Init6 will reboot it. It will go down and up. So let me do init6. So it starts killing the processes. Look at say, will not start. Now it starts reloading. So it went down and up. So now it's activating the processes. Look at now it does remember that its name is PC3. You see it in the corner here? You are in PC3. Here it's also you are in PC3, PC03. So let me enter as root, which is a bad practice, and my password is tool. Look at the prompt. Say you are user root in a computer that is called PC3. But it doesn't have IPv4 addresses. Why? Because the command that I used previously to put an IPv4 address was not persistent, which means that if I boot the computer, or if I am unfortunate and there is a power outage where the computer is, when the electricity comes back, the computer will go up, but it will forget its IP address. Why? I did not store the IP address in any configuration file. So there is a configuration file for the network part. So I'm going to edit this configuration file with nano. So nano, and the name is /etc for etc /interfaces /network /interfaces. So look at /network /interfaces. Look at the name. /etc /network /interfaces. And here we will have information of the two interfaces, the loopback interface and the Ethernet 0. So look, those lines that start with a sharp are comments. So this is a comment, this is a comment, this is a comment. A comment that say, here we have information of the loopback interface. We are not going to change it. And here it say, here we have information about the primary network interface. So look at here in the second line, we have iFace. This is a short. This is short for interface. ETH0. This is the name of the interface. Inet. So Inet is for IPv4. Inet6 is for IPv6. So let's keep Inet. And by default, it say get your IP address through DHCP, Dynamic Host Configuration Protocol. We don't have a DHCP server in the network, so my computer was not able to get its configuration through this protocol. So I'm going to remove DHCP and I'm going to put static. Static is a way to say, I will tell you what is your IP address. I will tell you what is your net mask. So with an indentation, we put address and we put the IP address of the computer. So this is PC3. The IP address of PC3 is, we can see it here, 10.20.7.30. This is PC3. And then we put net mask and the net mask that we want. We want /24, we put that. So you see, I changed here, it was DHCP, I put static. I specified the address, the IP address, and the network mask. I made a change, it is okay. So I need to save the change. Control O. It shows me the name, it's okay, enter. I need to exit, Control X. Now, it will still don't have the IP address because I make the change, but I didn't say to the computer, I did make the change in this file. Take them into account. So one way to tell the computer that I did change into this file is to reboot the computer. Because when you boot the computer, it's go on the configuration file and load its configuration. This is not a good idea to boot the computer, but we are going to do it because we are still not expert. Let me do an init 6 we did last time, no? So another way to boot a Linux machine, there is a command that is called reboot. I'm going to use this time the command reboot. So it will kill the processes when it go down, and when it go up, it will activate the processes. So here, it is killing the processes, stopping the processes. Now it's restarting the machine, so it is starting the processes. All these processes are starting. And now PC3 will have an IP address. So let me go to PC3. It's know that its name is PC3. Let me enter as root, tour, and let me type the command ifconfig. And as you know, it knows its IP address because I put it in the file, and its netmask because I put it in the file. So now it's persistent. So if you look at those slides, they will tell you about that. So let's see the slides. They are here, and we have, for example, the command that I typed. Those commands are not persistent. I use ifconfig, this interface, this IP address, netmask, and this netmask. I use this. This is non-persistent. Now, if I want the persistent version, here they say, for example, in PC01, you need to edit the etc hostname file. And you need to edit the etc network interfaces file. And in the etc network interface file, you need to have that. So I did put static here. Then I put address, the IP address. So this is PC1, of course. This is the IP address of PC1 and the netmask of PC1. So we did see the command ping. We did see the command ifconfig. Let me show other commands that are here. So there is something that is called the routing table. And to check the routing table, there is a command. This command is netstat, network statistic, -n for numeric, R for routing table. It will show me the routing table. So the routing table, we'll get used to it very soon. Say that if I want to reach any IP address that belongs to the network 10.27.0/24, so let me put it a little, let me redo it. So if I want to reach this network, the packet have to go out to this from my interface that is called ETH0, which means that this is the routing table of PC1. If PC1 want to reach any other computer, the packet have to leave Ethernet 0, the interface Ethernet 0. Of course, you can say this is the only interface that I have. So if I want to reach any remote computer, I have to leave here. That's true. But we will soon have computer with several interfaces. So when we have computer with several interfaces, when they will send a packet, they will have different choices. But this one, it's the first exercise. PC1 just have one choice. And if you want to reach any other computer, it have to send it out Ethernet 0, the interface Ethernet 0. Okay? So this is the routing table. You can see the routing table also with the command route -n. This is the routing table, another way to do it. There is a new command that is called IP. I want IPv4, so -4 show route. So it's route show. Route show. This is also the routing table. Let me do it again so you see it. So look, it tells me if you want to reach any IP address in this network, you must send the packet through the Ethernet 0 interface. Okay? Let me see if there is something else that I have to tell you in this lab. Okay, so let me make persistent PC1. PC1 is not persistent. No, we use command. Let me show you the command. They are in the history here. We use this command to put the IP address on the net mask. And we use this command to specify the host name, which means that if I reboot PC1, it will forget its name and it will forget its IP address. Let me reboot it. I'm going to use a third command to reboot it. Shutdown -R for reboot now. Killing the processes, and it will start the computer again, as you can see. So it's a third way to reboot the computer. Okay, you will see that the name is Debian. As you can see, it didn't remember its name. Let me enter as root. It doesn't have the correct IP address. It doesn't have IPv4 address at all. It has one IPv6 address. So inet is IPv4, inet6 is IPv6. So I want to change the IP address. I want to change the IP address of PC1, but I don't want to reboot it. So I need to edit a file. Before I do that, I can use, for example, a command that is called ifdown. Ifdown is to shut down an interface, to disable an interface. I'm going to disable interface ETH0. So if you look now, when I ask show me your information of interfaces, it will show me only loopback, the loopback interface. It doesn't show me the Ethernet interface anymore because I shut down it. I disable it with ifdown ETH0. So now I'm going to edit with nano the file of the network configuration, which is /etc/network/interfaces. Okay, and what I have to do here is remove this DHCP, put static, then put address. So the address, let's check it. The address of PC1 is 10.27.10. So let me put 10.20.7.10. The net mask is 255.255.255.0. Okay, change are made. So let me save the file, Control O, enter, and let me exit, Control X. If I look at my configuration, I just see the loopback address. Because if I want to enable now the ETH0, I need to use the command ifup ETH0. So enable this interface. When I will enable it, it will go through this file and find its configuration. So when I do ifconfig, now this interface is back. And as you can see, we have the correct IP address, 10.27.10, with a net mask of 255.255.255.0. Okay? So now if you reboot PC1, it will remember its IP address. It will not remember its name because I have not edited this file, no? The etc host name, let me do it. You see, say Debian here. I have to put PC01, Control O, enter, Control X. And there is another file, which is the etc host. And here, I say, no, you are not Debian at JSU. You are PC01 at jsu.edu. And the short name is just PC01. So this is called the short name. And it's called the full qualified domain name, because we have the short name at the beginning and the domain. Here, the domain is jsu.edu. If you work at IBM, the domain will be ibm.com. But the domain here is jsu.edu. So let me save it with Control O, enter, and let me exit with Control X. If I reboot the computer now, it will remember its IP address, no? So look what I'm going to do. From PC2, I'm going to ping PC1 forever. It will work, and I'm going to reboot PC1. So let's use this time init6. So of course, the ping is going to stop working at one point and then restart working because I'm booting PC1. So PC1 at one time is killing all the processes. The ping does not answer. It go down, and when it go up again, the ping have to answer. So let's see that. I did a ping 6. Look at the ping. The ping have stopped. I don't know if you realize it have stopped in 119. It's not working anymore. And now it's starting again. You see, it stops during some time. And of course, there were some packets lost. So let me stop it. Look, we went from request 30 to request 42. So we lost 31, 32, up to 41. So we lost like 11, no? So it said that of the 51 packets, he received 40 answers. So 11 were lost. It was what I was telling you. So it say, this is the percent. 21%, which is 11 out of 51, were lost. And the statistic, the minimum, the average, and the maximum round trip time. Okay, when I'm done with this lab, I need to shut down the machine. It's like when you go to sleep, you shut down your computer, or you put it to sleep, maybe. I'm going to shut down those machines. So one way to shut down them, I already showed you, is init 0. I'm going to shut down PC2 here. I'm not root, so it say you cannot do it. So let me switch as root tour, and then I put init 0. So it's shutting down the processes and the screen disappear. The monitor is off. Still have the monitor of PC1 and PC1 is running. I still have the monitor of PC3. And if I go to GNS3, PC1 is on, green, PC3 is on, green. So I'm going to shut down PC3. So I can do init 0, or I can do halt. There is a command that is called halt. I can just use alt. So I'll do the same thing, kill the processes, and then, as you can see, it was PC3 that I don't remember if it was PC2 or PC3, but both of them are off. Now I'm going to do it with PC1, but I'm going to show you another command. So let me enter as root, password tour. So I'm going to use the shutdown command, -H to say halt. Now, so the shutdown command, you say, okay, halt in 1 minute, halt in 2 minutes, halt at 11 p.m. So you can program when you want to shut down the computer. If I say halt now, which means go now. So all the commands of Linux have a manual. You can do man shutdown, and we will have the description. So look, I did use the option, for example, halt, the option reboot. I put the time when I want to halt it or reboot it, no? So here, look at, if you use -R, it will reboot after shutting down. If you use -H, it will halt and power off the machine. Okay, so you have information about what to do. On the time, I put now, when to shut down or when to reboot, no? So here they give you more information about the time. You can say, for example, shut down at a specific time, or shut down in 1 hour, or shut down in 30 seconds. You can do all this. So here they say, for example, you can use HH:MM. First, it can be an absolute time. That will be an absolute time. So if I want it to shut down at 11 o'clock, I should do what? I should do shut down. And the time will be 11 o'clock. 23 hours, no? Because if I put 11, it will be 11 a.m. So it will be tomorrow at 11. I need 11 tonight, 23 hours and 0 minutes. Okay, so in which hours is the hour, 1 or 2 digits, and MM is the minute in 2 digits. Okay, so this is what they say. I can specify a specific time, but I can specify some also, for example, shut down in 10 seconds. So let me shut down this. Alt now. Or I can do now plus 10 seconds. Oh, it's not like that. Let me see. So it's not now plus 10 seconds. Try now. How do I? If I want to do it in 10 seconds. Okay, good opportunity to read the manual and see how we do that. When to shut down. Let me see. Okay, just plus second. It can be of the format plus M, in which M is the number of minutes to wait. So there is no way to say, but I can do +1. It will be shut down in 1 minute. So look, it says here, the system will be halt in 1 minute. So it will wait 1 minute, and after 1 minute, it will shut down the system. Okay, so why it's shut down? Because we asked 1 minute. Let's see the other exercise. So we have another exercise here. Let's discuss this exercise. So this network is more complex. What can you tell me about this network? We have a router here. So how many network we have really? We have 3. Each interface of a router is a different network. So here we have a network. We have this switch in the network, this PC, and this interface of the router in the network. Here we have a second network. This switch is in the network, this PC in this interface of the router is in the second network. And here we have a third network. Look at the shutdown now is doing its work. So if I look, all of them are shut down. So I can exit GNS3. Remember, this project is called Linux Lab 01. Let me exit GNS3. You don't have to save. GNS3 save automatically the project. Are you sure you want to exit? Yes. Okay. At the other day, I want to continue with my practice. I come back to GNS3. So it's telling me what is the project. So here, open a project from disk. I can click it. It will show me there is only one project in this moment. It is called Linux Lab. Double click in this directory on linux-lab01.gns3 is the file that I have to open. And it will show me the network again. So if I want to start PC1, right click on PC1, start it. And of course, if you have made a persistent configuration, PC1 will have the information that you say, no? Okay, let's go back to this. So we have three networks. Look at this network. This network here is the 192.168.00/24. This network here is the 10.2.5.128/25. And this network here is the 170.18.0.64/26. So if I ask you what is the IP address of PC05, what will be the IP address of PC05 when you configure PC05? Exactly, 10.2.5.130. What will be the net mask that I will have to configure in PC05? Correct. So the net mask of all the devices, PC05, PC06, and this interface of the router will be a /25. And the /25 is 255.255.255.128. Let's see PC01. What will be the IP address of PC01? Correct. It will be 192.168.0.10. What will be the net mask that I have to configure in PC01? Correct. Okay. So it will be a /24. So PC01, PC02, and this interface of the router should have a /24, which is 255.255.255.0. Okay. Now look at router 1. Router 1 has three interfaces. One is called Ethernet 0, another one is called Ethernet 1, and another one is called Ethernet 2, sorry. So let's say that the router have a packet for PC05. What should the router do with this packet? So the router has three interfaces. It can send it to Ethernet 0, it can send it through Ethernet 1, or it can send it through Ethernet 2. So if it wants to reach PC05, it have to send the packet through which interface? Ethernet 2, correct. So the routing table will reflect that. The routing table will say, if you want to reach any device in this network, you need to send the packet out the interface Ethernet 2. Now, if the router have a packet for PC04, it have to send it out through this interface, Ethernet 1. And if the router have a packet for PC01, for example, it have to send it out through this interface. So the routing table of router 01, when we finish the lab, will reflect that. Now, what will happen if PC05 want to reach PC06? Yeah, it has to go through the switch, but the PC have only one interface. It is called ETH0. It is not in the figure because it will put too many information. But the PC have only one interface. So if PC05 want to reach PC06, it will have to send the packet out interface ETH0. Now, PC5 know that PC06 is in the same network as it is. They share a common network. So when PC05 will try to reach PC06, it will not ask the help of the router. It will send it directly to PC06. Now, when PC5 wants to reach PC01, what will happen? Can PC5 send the packet directly to PC1? No. So PC5 to reach PC01 need the help of the router. So PC5 will send it first to the router. Then the router will forward it to PC01. So we need in a routing table of PC05 something that will say, if you want to reach a device that belongs to the local network, which means the network where I am in, I don't need the help of the router. I can do it by myself. Now, if I need to reach a device, I'm PC05. If I want to reach a device that is in remote network, for example, for PC05, this network is remote, or this network is remote. For PC05, this network is local. This is my local area network, my LAN. This is a remote LAN, and this is a remote LAN. So the routing table of PC05 will have to say, if I want to reach a device that is in a remote network, I need to send it to the router. So this is called the default gateway. The gateway is how do I exit my local area network and reach the rest of the world. So for PC05, the gateway will be the IP address of router 1 in this interface. So the gateway that we are going to configure in PC05 will be 10.5.129. The gateway that we are going to configure in PC6 will also be the same gateway, which is the IP address of router 1 in this interface, which is 10.2.5.129. So if I ask you what will be the gateway of PC04? What will be the gateway of PC04? So what is the gateway for PC04? If PC04 needs to reach a remote network, it cannot do it directly. It needs help of someone. So the help that PC04 needs is the help of router 01 in this case. So we need router 01 have 3 IP addresses. The gateway for PC04 will be one of these 3 IP addresses. Which one do you think it will be? Yeah, the one that is on Ethernet 1. It will be 172.18.0.65. So if I ask you, what will be the default gateway or the gateway of PC02? Correct. It will be the IP address of router 1 in this interface. So it will be 192.168.0.1. Okay? So when we are going to configure PC6, we will have one more information that we didn't have in the previous exercise. Why we didn't have that in the previous exercise? We didn't have a gateway. Because in the previous exercise, we just have one network. Look at the previous exercise. We just have one network. So there is no router. There is no way for me to reach a remote network because I'm not connected to a remote network. I'm just connected to one LAN. In this new exercise, it's a little more complex because we do have remote network, okay? In the new exercise, we do have remote network. Let me show you a third exercise that we are going to see also. No, a fourth exercise, so it's has to be the next slide. Give me a few seconds, we see these slides, and we can go. I forgot to copy it. So lab, and the one that, so it will be the 4. Yeah, it will be the 4. Look at this network. We have 2 routers. Let me see if we have IP addresses. Okay, we have IP addresses here. What will be the default gateway of PC05? What will be the default gateway of PC05? PC05 is this PC. So it will be the IP address of router 2 in this interface, which is 22.7.8.129. If I ask you what is the default gateway of PC1, it will be the IP address of router 1 in this interface, which is 1.1.1.1.1. So what will happen when PC1 wants to send something to PC3? So PC1 will send it to router 1. Router 1 will send it to router 2, and router 2 will send it to PC5. This is called a hop. First hop, second hop, third hop. So look, we never talk about the switches. Here we have switches, and we kind of ignore them. We never talk about them. The switches are transparent. They are there, but it's like they are not there. So the PC don't know that the switches are there, and the router don't know that the switches are there. They don't have IP addresses. So the router in each interface will have an IP address. The PC just have one interface, so it will have an IP address in this interface. But the switch, which have several interfaces, will not have IP addresses, as we will see. Okay, so remember, please, I will send the link of the virtual machine. You download the virtual machine, you uncompress the virtual machine, you start it, and you try to redo the same exercises. So there is something that I need to tell you. You need to activate in your laptop virtualization support. Do you know how to do that? When you boot your laptop, there is a way for you to go to the BIOS. You go to the BIOS, and in the BIOS, you will find a way, an option to enable the virtualization support. If you don't do it, when you try to start the virtual machine, it will tell you, it will give you a warning. You need to enable the virtualization support. Okay, because we are using virtual machine, so you need to enable the virtualization support. If you don't enable it, you will have this warning. And remember, you need to install VMware Workstation Player. This is the free version. And it will ask you a license. Just say that you are going to use it for academic purpose. Since you are going to use it for academic purpose, it will not ask you the license anymore, and you will be able to use VMware Workstation Player. Okay, thank you, and I see you in 2 days to continue with this lab.